In this video, we'll create an analytics application from scratch. We'll use AWS Kinesis, AWS Redshift, and Retool. As a source of data, we're going to look at the top Hacker News posts. We'll see how many posts are related to a certain topic of interest and what the sentiment is for those posts. That is, are they more positive in their language, or are they more negative? For example, we could look at the posts that talk about Python, the programming language, and discern if those posts generally use positive or negative language. We'll also see in the analytics how often the topic is discussed over time. As usual, we'll quickly understand what we're trying to achieve visually, and then look at the code, configurations, and systems required. For a simple example, we're going to use our local workstation to collect data and push it to our data pipeline within AWS Kinesis. AWS Kinesis will serve as a sort of data pipeline. It will collect data and then load it into our data warehouse, AWS Redshift. The last system that we need is Retool. We'll use the SaaS version of Retool to set up an analytics application. We'll be able to understand the data through visualizations in this application. This final data presentation layer, Retool, will be the point of interaction for our users. So the data will generally flow from our workstation to Kinesis. Kinesis will load that data into AWS Redshift. And Retool will consume that data in Redshift. Retool will present the data in a meaningful way, so that users can gain insights from the data. Let's talk about prerequisites for this tutorial. First, you need to be comfortable using Python in your local workstation. That includes both running scripts and managing dependencies. You additionally need to have an AWS account set up, including a user which has permissions across AWS Kinesis, S3, CloudWatch, and Redshift. You'll need the access key and the secret for that user, because we will be using programmatic access to AWS. And the final prerequisite is an account with Retool. All the code and configurations for this setup, as well as some high-level documentation and instructions, are provided in a public GitHub repository. There's a link to that repository in the description of this video. From there you can reference important commands from this video, as well as copy-paste them. You'll also see any updates since the publishing of this video. For example, changes may be needed to accommodate changing AWS client libraries. As an additional quick detour, we'll look at using Terraform to be able to automatically provision these AWS resources. If you use the infrastructure as code approach, then you use your local workstation and the Terraform CLI to provision the required AWS resources across both Kinesis and Redshift. This is an optional step, which we'll review briefly. The main path is a manual setup of these resources, using the AWS Management Console. Again, all the code and configurations required for this system can be referenced and copied from the public GitHub repository. Let's start now in the AWS Management Console. We first need to set up the Kinesis fire hose. Kinesis fire hose is in the Analytics category. Make sure you have the desired region selected. We could set up both a data stream and a fire hose for this application. However, to keep things simple, we'll use just data fire hose. We'll send records directly to that service. We're going to name our delivery stream on Hacker News. We'll use the direct put option. From our workstation, we'll be directly putting records into Kinesis. We will not be transforming the data with AWS Lambda or converting the record format. Our destination is a data warehouse, Amazon Redshift. Note that we'll be using an S3 bucket as an intermediate format and for backup. Using an S3 bucket between Firehose and Redshift improves the efficiency of the insert copy operation. Further, the backup allows us to have plain text file backups of the records that we pass through the data pipeline. In some sense, S3 is acting as our data lake here. We don't yet have a cluster, so we'll create a new one. Click to create the cluster, making sure we're still in the same region. We'll name the cluster on Hacker News. Selecting the free trial option is recommended if it's available. And remember to delete all the resources we create in this tutorial once you are done. These resources are not free, and if you forget to delete them, the cost could be substantial. For the database name, we'll use on Hacker News. We'll leave the port as default. We need to set up a username and password. Make sure that the password is sufficiently complex. Also, make sure to note the password, because we'll need it later. I'll use this password, but use your own. Do not use this same password as I'm using here. We'll leave the defaults for the rest of these fields. It will take some time to create this cluster. Once the cluster has been created, we can use that in our Kinesis Firehose setup. Here we'll put in the username and password that we defined earlier. These must be the same username and password that we used when setting up the Redshift cluster. The database is on Hacker News. And the same for the table. Note the underscores for both the database and table. Leave the columns blank. And for bucket, we'll need to create a new one. We'll call this on Hacker News and specify some text at the end. S3 buckets need to be unique, so specify your own set of random characters at the end here. Or else you'll get a conflict with what I'm creating here. And we'll set up a backup folder as well. For the copy command options, we want to use JSON Auto, which means Firehose will read the records that we send from our local workstation. Firehose will read that in the JSON format and map that automatically to database table columns. Using this approach requires that we use the exact same names between our JSON fields and our database table columns. And that we overall have a mapping that can be inferred by AWS. We'll set the buffer size low, so that we quickly have data saved into Redshift from Kinesis Firehose. Setting a large interval and size buffer means that Firehose collects a lot of records before loading those into the database. For our simple tutorial, we'll use the minimum values. We'll leave encryption and compression disabled. However, we'll enable error logging, so that we can have CloudWatch logs. The logging will be helpful in the case of any problems. Finally, we'll automatically create an IAM role. Click to create the delivery stream. And now we'll need to set up a couple of last things before our data pipeline will correctly send data to AWS Redshift. First, we need to make sure that our pipelines can reach the Redshift cluster. So go back to Redshift. If you don't have that tab open anymore, note that Redshift is in the Analytics section here, or you can search for it. In Properties, for our cluster, we're going to open up the Security group. If we look at the bottom pane, in the inbound rules, we'll need to make sure that Redshift can be accessed from any IP. So, if you don't already have these records, go into Edit Inbound Rules. Add a rule that any traffic can access the Redshift cluster. Note that for production applications, you may want to further look at the IAM security and networking security. This will be sufficiently secure for our tutorial. We'll still need a username and password to connect to the cluster. Finally, in your Redshift cluster, make sure that the cluster is publicly accessible. While this is updating, we can look at the Python required to collect and send data from Hacker News. I'll start with a new virtual environment for these dependencies. If you don't already have VENV installed, and you're using the App Package Manager, you can install with something like this. We're going to set up a normal virtual environment. No matter what approach you prefer, somehow get a virtual environment set up with Python 3, and we'll install the required Python dependencies into that virtual environment. First, remember to activate the virtual environment. OK. We successfully installed. And now we can run the data collection. Note that you'll need to provide arguments for the cluster endpoint, cluster username, cluster password, and firehose region. We'll get the endpoint from Redshift. That's this value here. And we want just the domain and the port. We don't need this slash on Hacker News. Provide a username. And you can use the short or long versions of these arguments. Just for improved clarity, I'll use the longer versions. And we'll also need to set up the AWS credentials. We need to export two environment variables, the access key ID and the secret access key. Run exactly these commands if you're using a bash terminal. And of course fill in the placeholders, using a user that has sufficient permissions to send records to Kinesis. I will do that now out of view. And once you've set those two environment variables, go ahead and run the script. Now note there are two sets of credentials here. First is what we're providing in these environment variables. That includes the endpoint username and password. Those are to authenticate with your Redshift cluster and run SQL commands. In this case, we're making sure our table exists in the database before loading data. The second set of credentials is AWS credentials for sending records to Kinesis. You don't need to understand all the details of this particular script. A few things are worth noting, however. First, at the top are some constants that you may want to change, particularly this interest here. Right now, I have the interest set to Python. Make sure you use all caps and pick something that you're interested in. When we look at the analytics, they will be based on this interest value. The analytics will help us understand the activity around this topic, and if that activity is generally positive or negative. This will take about 2 or 3 minutes to run, regardless of what value you decide to use for the interest constant here. And note that it takes some time because we are building in pauses between requests to the Hacker News public API. Specifically, we're using a 1-second wait. That's to make sure that we don't hit the API with too many requests in a given period of time, which could lead to our IP being blocked. We also don't want to, from a respectful API use standpoint, hit this API with too many requests. So, we'll spread out the requests, less than 1 per second. Once the Hacker News data has been collected and sent to Kinesis, we can use Redshift to make sure that the records ended up in the data warehouse correctly. If we query the cluster, by first connecting to the database, and then running a select command, then we'll see all of our records. We see the time that the data was extracted. And this is an epoch time. We see the title of the Hacker News post and how many times our string of interest showed up in the title or URL. We also see sentiment scores, how positive, neutral, or negative the title was. A compound value combines the 3 sentiment scores. And now we have data that we can use in a Retool application. So this is our last step. Log into your Retool account. And if you're presented with an onboarding page, just click into the Retool logo in the top left to get to this home page here and create a new blank application. From here, click on the triple dots, then click on Resources. Click to create new. And choose Amazon Redshift. Name it something like on Hacker News and provide the host, port, database name, username, and password. Also, be sure to connect using SSL. If you get the values from the AWS Management Console, most of the required information is in this endpoint value here. The database name is at the end of the endpoint, as well as the port. The host is here. Use the same username and password that you have used throughout the tutorial. and connect using SSL. Test the connection to make sure that it works. And then create the resource. I've already created the resource myself. And when you create it, you'll see it in the list of resources. Back in your application that you created, we can now use that resource. There is a query that's automatically created, and we'll rename it to On Hacker News. Select the Redshift resource that you just created. What we're going to do is pull the required data that we want to graph. Part of that query will involve using a date range picker. So if we drop this into the application, we can go ahead and move it into the header. Creating components like this is done with a drag and drop from the right sidebar. Now, we'll have a component to use for that query. Name the component dates. And then copy the SQL from the GitHub repository. The SQL includes these values for filtering. What this SQL command does is it gets the time of extraction. And it converts that to a date with this truncate function. It also gets the total count of times that the string of interest shows up in the title and the URL for the post. It categorizes the compound sentiment score into 5 categories. If the sentiment score is very low, then it's a -2. And then progressively it moves up to higher thresholds until the highest value of 2. So this is very low. This is low. This is neutral. This is high, and this is a very high score. Based on the ranges, we'll have plain text values, as well, that describe these values in plain English. All this logic here just creates categories for our sentiment scores. And at the bottom we're going to filter by the dates that we select in the application, in Retool, and order SQL results so that we get very negative, neutral, positive and very positive, in that order. It's important to present results in that order specifically, and not something like alphabetic, which could be confusing to interpret. So copy the latest SQL from the repository and paste it into the application. You can save and run, but if the dates aren't specified, then there will not be any results. Okay, so we have no results here. Let's add our start and end dates. We want to have defaults, so that these don't need to be configured before using the application. By default, we'll set the start date to 30 days before the current date. We'll use this moment function and subtract 30 days from that. We'll set the default end value to be today's date. These values are going to be inclusive. Now there's a default time range for which we'll view the analytics. If we run our query again, we will get more results. Next, we can add a chart visualization into the main section of the application. If I drag the chart in, we'll take up more of the visual space. And we'll set the data. You can establish basic configurations rather quickly. However, there are a couple of additional changes that are not supported by this view. These are helpful changes, but they are only available in the JSON configuration, so we'll use that approach. We'll use the JSON from the GitHub repository. Now, in this chart, we have a view into the topic activity and sentiment. We can track, over time, how often our topic of interest shows up in Hacker News posts. We can also track the sentiment around that topic over time. If you'd like to see multiple days in the chart, we can do that rather easily by going to Redshift, clicking Query Cluster, and then running an update operation on that cluster. We're going to update on Hacker News and update the extraction date. We're going to set that back by 1 day. Once that update completes, we can rerun our collection script to gather data for today. Now, the data that we just updated is no longer accurate. It has an inaccurate extraction date. However, this can give you an idea for what the chart will look like as multiple days of data accumulate. While we're waiting for this to run, we can add some additional components to our application to improve the appearance. Let's add text in the header here. This is going to use a markdown format, so we can make a title. We can also add a button to refresh the data. Updating the dates will also refresh the data. With this button, we're going to choose an event handler. Click Trigger Query, then select our single on Hacker News query. Now, when we double-click, it will update the data. We see that some data is starting to come in from our running data collection script. If our script ran to completion, and if this data was accurate, we'd see that there is much more activity yesterday on the topic of Python. Overall, those Python posts have a very positive sentiment. We see no negative scores when people are talking about Python in their Hacker News posts. Now, with this basic concept of using Kinesis as a data pipeline, S3 as a data lake, and Redshift as a data warehouse, we can collect a lot more data. We use this architecture as a sort of minimal data collection and analysis system. As a final, optional step, we'll look at using Terraform to automatically create the resources that we previously created manually in the AWS Management Console. While the script runs, we can go to the Data Platform folder, and you'll see a Terraform file here called Kinesis TF. You'll first need to run a Terraform init to initialize Terraform, and then Terraform apply to provision the required resources in AWS. Again, you'll need to have those environment variables set for AWS authentication. But once those are set, you can run this provisioning. And we have not exported the credentials in this terminal, so we'll go back to here. Wait for this to run, And then we'll run the Terraform provisioning from this terminal since it has our AWS credentials as environment variables. For the sake of time, I'll stop this script a little bit early. Refresh the data and see the latest for our data collection. And now we are at a good point to stop and delete our manually provisioned resources. By deleting these resources, we'll avoid resource naming collisions during Terraform provisioning. So, let's first delete the existing Firehose and Redshift systems. The S3 buckets must go as well. Now we'll see, by running the Terraform apply command, how we can automatically provision all of the required AWS systems and configurations. Once the provisioning completes, everything is completely set up on AWS. We don't need to log into the management console in our browser at all. We can just use these output values in our data collection script. As usual with this script, make sure you have the virtual environment activated or the required packages installed globally. And now we're loading data into the automatically provisioned infrastructure as code data pipeline, data lake, and data warehouse. Since we deleted the original Redshift cluster and all our other manually provisioned AWS resources, our original data is also gone. Provisioning will create a fresh new cluster, but without data. If we refresh the data, we'll see either no data or, once data loads, a single day of new data. Indeed, in our Retool application, we are starting to get data in that fresh new cluster, a few records. One of the benefits of using Terraform for provisioning is the ability to very quickly tear down the infrastructure. We can remove the infrastructure just as easily as it was spun up. Just like the provisioning, we can do this without even logging into the AWS Management Console. If I cancel the data collection and move to the Data Platform folder, with the AWS environment variables set for authentication, we can run Terraform destroy. That command will remove all of the resources that we just automatically provisioned, leading to a blank state as before the provisioning. If you manually set up resources in AWS, this is just another reminder to delete everything once you are done so that you don't have surprises in your AWS bill. With that, hopefully you can see how to incorporate AWS services and Retool into a data collection and analysis application. We additionally looked at how to use Terraform for infrastructure as code cloud resource definitions. This approach has many benefits, but manual setup is always a good place to start. Please consult the public GitHub repository for instructions, code, and configurations. Hopefully this video was helpful to you. Thank you for watching.